So sorry, Jenny had me muted. I guess I'll do a couple housekeeping things real quick. First thing, I want to give a gigantic thank you to Paul Kuchera and Jenny Bolton, because they're what make this happen with the support contract they have with us at OSTI Modeling. Let me finish. Next, I want to completely embarrass and call out the people from my team that actually do all the real work. I'm just your MC. So I want to give a huge thank you to Will Kamarami. I don't know if he's in the room because he went to check out. Jason Anderson and Shira Francis. Guys, can you raise your hand real quick just so people know who you are? Thank you so much for coming down here and humoring me with your time and helping me not look like a moron. And then next would go to everyone that helped plan it, which is a lot of people, for figuring out the presenters, the schedules, the topics, especially Frank, Gopal, Avichal, VJ, and then pretty much half of NHC, I think, as well. So thank you guys all for your help. And Frank Indiviglio, whenever you are ready, go ahead.
You guys have my slides? You want me to present them? I did put them in there late, though. I was a bad presenter.
We're having a hard time hearing you, Frank.
Okay. Can you guys hear me now? Is that better?
Yeah, hold on. We're going to turn the volume up a little bit.
Okay.
Oh, he's in a hotel room on a laptop. He probably didn't bring a mic with him. Frank, go ahead.
Is this any better? Or?
Yeah, that's good.
Okay. Do you guys have the slides, or should I just put them on?
You can go ahead and share them for your end, because I'm not sure if we have them.
They're in there, but okay, that's fine. But I was late to put them in there. It's my fault.
Okay.
Excuse me.
Yeah, if you don't mind sharing them.
Yeah, I got them. We're good.
All right, thank you.
Just make sure. Put them in presentation mode. One second. Set up slideshow. Okay. All right. Can you guys see him? Okay.
Yeah, we can see it. Can you put it in slideshow mode?
It is in slideshow mode.
Oh, it is? Because we can see the sidebar on it.
Here, let me stop, and sometimes it doesn't like caching. Hold on. How's that? Better?
Perfect, thank you.
Okay. Good morning, everybody. Sorry I wasn't able to join you in person. I'm still supercomputing. Radek got to leave early, but I was stuck here until about 6 last night and couldn't get there in time. So thanks for letting me join remotely. I think I know everybody, but just in case, my name is Frank Indiviglio, and I'm the Chief Technology Officer here at NOAA. We're going to talk about HPC a lot, but there is a wider context here, right? There's a little bit more going on in the technical world. So we'll start with where we are, talk about what's out there, what's changing and what's not changing, and then what I think we need to kind of look at going forward. So, I think everybody's seen this slide. I like this slide because it's a good slide to show folks about what we do in modeling. But I think this slide, although because it's a really good tool to communicate that, I think right now is incomplete. Right? This is a good way to show how compute is consumed, but there's a missing access, right? Where things like artificial intelligence, machine learning, whatever you want to call it, I think will add to the complexity that exists in our environment. So I think we have to really think about how that gets integrated, and as that as that ecosystem around AI changes, it will change the way we do HPC, it'll change the way we do processing, and it'll change this thing. I think it'll change this slide and make it better, right, for everybody. So I think we're in a changing world, and that's been a kind of theme, even at we were talking about HPC all week out here. I think that's a theme across the industry. So again, I think this is a good place to start, because we're already in a complicated environment, but it's going to become more complicated. So I think one of the things that we really need to think about is how do we deal with that complexity. So our prediction environment, our prediction is complex. Our computing environment is complicated too. So how is it complicated? Well, we have multiple systems, right? Radek, I had the map up, and I've shown you that map probably a bunch of times too. So we have 5, 6 computing environments that people utilize right now. They all have their own kind of intricacies, and I would say cultures, and it's a good thing. But there's reason for them, and there's a good thing that they have them because they get their jobs done. But that adds to complexity, right? That adds to your time moving from one system to another. So, going back to having, talking about utilization and people's needs, making that less complex for you, I think is one of the goals that we should talk about, because transition time shouldn't be in weeks, in my opinion. It should be days and probably less, right? But that means a lot of things to think about, right? Not just the software environment, there's workflows, there's other things that have to go into that. So that's the first level of complexity, right? How do we look at, managing or abstracting multiple systems across our enterprise and all the other places that you or your collaborators or your scientists run across, right? It's not just NOAA, it could be outside of NOAA, it could be in the cloud, it could be, at a university. There's lots of options for that. And how do we make that an easier environment for you to live in? The software, just in general, the software environments are becoming more complicated because we have growing software choices, right? A lot of you download libraries on a daily basis. We use different things. Our tool sets are growing, and when you talk about things like machine learning and AI, those things change at almost weekly, if not sooner, or more frequently. So we are living in a faster pace of software than we have before, and there's more choices in that software. So how do we manage that, right? We're working with multiple systems. We have a growing software ecosystem. How do we manage that, and how do we get the tools that you need in your hands in a secure way, so that you can trust the computing environment you're using and get what you need to get done. And on top of all this, we have shrinking compiler choices. So we have growing software choices and shrinking compiler choices. So with the hardware, and we're going to talk about that later, that's growing, the compiler choices that you will have are not they're not as robust as I would think as they used to be, right? There's a lot of open source development and compilers. I think that's good, and I think that'll shift the market. But there are whole hardware companies that don't have a compiler set. So that's good and bad, right? It's good because you can use open source options, but it's also, I think, a challenge because some of those things don't line up with compilers that we use, right? So if you say an Intel compiler on an AMD chip, for 95% of the instructions that you'll try to use, that'll be fine. But there's 5% that will give you hopefully apparent wrong things, but we don't know until we know, right? So there's complexity there too. So it's not just multiple systems, it's not just this growing software environment, but we have to make really foster, I think, the compiler environment across all of this, so that you have choices, you have tools, and we know how they work. So if we take a look at what the environment looks like, our prediction is complicated, our software environments are complicated, our system environments are complicated. What should our goals be, right? And I think from my perspective, our goals should be reducing time for you to get productive, right? So I want to get that transition time if you have to move from one system to another, or from cloud to on-prem or back, or whatever that is, right? We want to reduce the time to get productive. That means looking at the software environment, adding some abstractions, and really working with everyone to get the workflow, all the workflows that you have that are really important to what you do, to be not portable, but how do we adapt the environment to make your workflow work, right? What are the atomic parts that we have to provide to that workflow, so that transition is not a rewrite or a port, or weeks worth of work from someone on your staff. So reducing time to get productive, that I think that's got to be our most important goal, right? How do we move you around without, or give you new resources without being a burden on you and your staff? Second thing, and we talked, like we ended the last talk about GPUs in the questions, access technology faster, right? So we provide GPUs, and we've done that in the past, but there's a lot of things out there now, right? So NVIDIA, and again, we'll talk about hardware when I talk about the market a little bit more, but NVIDIA has an ARM chip now. So ARM is it's not very different, but it's a different architecture. How do we get that stuff into people's hands faster? How do we give you testing environments? How do we support your porting or testing environments there too? So it's not just getting productive faster, but it's getting to technology faster. And when we get to things like cloud, I think, how do we look at adopting technology and engaging with it faster, right? So what are ways that we can, if you want a cloud service or we want something else, there's security things that we have to go through. There are IT processes that have to happen. I think there's ways that we can streamline this, right? How do we come up with, sandboxes for folks to test ideas at, and then, and grow that from there. So I think there's a lot of discussion around that, especially in my organization. I don't want to be right. This is all about getting you productive faster. How do we get things into testing faster? How do we get a pipeline for you to be more productive, right? So I talk about this a lot in software development, or I used to, and there's like a 3-part process in my head about how we do software development, or how we can do software development, right? People reaching out really far, out front, and then in the middle, people are making it accessible, and then the last step is getting it, into your research stream. And I think the same thing is true for services, right? How do we build a pipeline to make smart choices about what we engage in, and then what we turn into research and hopefully operations at some time. So we'll switch there. I think those are my big points about. I'm sorry, I'll go back to this. Those are my big points about what I think we need to think about. In talking about a vision of where we need to go in the future. These are the things I think we need to do. Like, where are the abstractions? How do we get technology faster? How do we accelerate our engagement and adoption cycle? And I realize that we have to test, we have to be rigorous, we have to do the right things. But where are the ways that we can all work together to make that move a little faster? So let's take a look at the HPC market, just to kind of give an update of where we are. I thought it was a good thing, since Radek and I have spent the last week talking about it. So while it's fresh in our heads, we'll give you kind of an idea of where things are in terms of technology and where they could go. So this is not my slide. I took this from Hyperion Research, which is one of the industry research of firms in HPC. So this is to give you an idea. So HPC is still a large industry. It's about a $40 billion industry. Most of it, almost half of it, 41, is still on-prem. So think big machines like we have at Fairmont or Oak Ridge, and other places. Cloud is about 17% of the total market. Services is about 6%. Application and middleware, is about 20% there. And then storage is 17%, which surprises me because our storage needs continue to grow, and they don't grow the same way as the compute needs. But this is the whole market and not just us. So this is a rebound, right? So the market had shrunk because of supply chain to about 20 billion. So it's surging again. So that's kind of the whole market in terms of processors. And I'm only putting this in here just to kind of talk about what I think we need to think about as a community, right? So processors, there's going to be a lot more variety that we'll have access to. Not only in the type of, but in the packaging, right? So let's just start with what we know, right? So x86, which is the processors that we use for almost everything in NOAA, they're getting bigger, right? They're not getting faster, they're getting bigger. So now the current generation of systems that you'll see coming out in the near future, they'll probably be 120 cores a socket or 256 cores of per node, right? So at a dense packaging, that's 256 nodes times 256 cores. That's, I think it's 32,000 cores per rack, right? So we're getting to pretty big system sizes just in a rack space, which is great, but there's limitations, right? Memory bandwidth and IO bandwidth will still be the limit. So the last time I talked to a group of you about technology, I said, oh, there's 64 cores per socket and 128 PCI lanes. And now there's 128 cores and 128 PCI lanes. So while compute capacity grows, IO still becomes a choke point, right? So that means access to memory, that means access to disk. Now, there are things that are going to change in this area, and I'm getting pretty excited about them. But I wanted to point out that there's still kind of we're going to lose a little bit of balance on the x86 side because of that. Now, do those challenges exist in other places? They do, but there's something to think about when when you're thinking about your modeling. For GPUs, they continue to grow. I mean, we just talked about it in the last talk with Radhika. We're adding those. Radhika's adding those into the purchases that are coming through. So about a third, that's probably growing. The top 100 contain GPUs. All the top 10 do, with the exception of number 4. That's the Japanese. That's Fugaku. That's ARM. So it's not even x86, right? So either the top, if you're in the top 10, you're either x86 with GPUs or you're not x86, right? So to kind of give you an idea of that. So GPUs are evolving. The software around them is evolving, right? So NVIDIA obviously has, I think, and you guys probably know this, the best, I think the most prominent and probably the most mature software stack around GPUs. And that extends from HPC to AI, right? So we are now looking at, really highly powerful GPUs that are in a good package, that are they are a little bit more power hungry. The nodes get pretty power hungry. We're looking at 500-800 watts per node. But they're multi-instance. They have a lot of AI focus. You can see differentiation now in the market where GPU packaging is changing, right? So NVIDIA has different packages for AI and HPC. Intel has, I think, 3 or 4 different ways to buy them, right? Just for AI, just for deep learning, just for HPC and other things. So they are specializing now, right? So you're getting to large core counts, large memory, and in some cases, the limitations that we had before, like access to system memory, may go away, right? So NVIDIA is releasing an ARM product, and that's my next slide. So it's kind of, let me say this a couple times, but that product has can sit with a GPU, and that thing has direct access to the system memory. So the limitations that got in the way before may be going away to some extent. So that's an evolving thing that we need to keep an eye on. Specialized accelerator and processors. There's a ton of upside potential for this, in my opinion. With ARM and RISC-V, these are open standards that people can implement. You can see a lot of diversity now. I mean, even the big producers do it, but now even the smaller ones do. So companies like Next Silicon and others make their own chips. They're specialized for domains. They're specialized for I/O patterns. They're specialized for a lot of other things, and they have GPU parts. They have CPU parts. They have other accelerators. But you can see Intel doing that too. So they have a Gaudi product, which is just for deep learning, but it's basically an x86 with a lot of different cores around it to do deep learning. And you can see that diversity really picking up with the open processor standards. So ARM adoption continues across the industry, and I think this is a really interesting thing to look at because it's an easy thing to test. There's not a lot of rewriting that has to happen. There's a lot of tuning that has to happen, but not a lot of rewriting. So if you look at large adopters, so NVIDIA just released, or is in the process of releasing their Grace product, which is a 96 core ARM processor. The benchmarks I've seen are pretty good. I've asked them to actually benchmark as much of our open code as they can, so they're looking at doing that. But companies like Apple, I mean, all the MacBooks now or M3, they're ARM, and there's other companies that are doing this, right? So you can see a lot more, and even the big silicon providers are now looking into different standards. So the standards continue to evolve. They increase the feature set, so I think this is going to keep growing. And RISC-V, which is, excuse me, a similar product line, is evolving in the same way. So, but I think it'll be much faster. So ARM took about 20 years to become something that we're looking at. I think RISC-V will take 10, maybe 5 if they move fast enough. But I think they've learned a lot. I think they have a more attractive model for folks that want to do chip production. So we're starting to see small products on the small end come out, but I think that's something that we'll have to think about too. All right, so software. So exascale, and I guess we start talking about post-exascale now because we're in the exascale era, right? We have at least one, maybe two that soon that'll be exascale. I think the real, not concern, but I think the thing that we have to watch is there's really no coherent Fortran only strategy in the community, right? And that may or may not be a hurdle for us, but it's something that we got to think about as we think about exascale, right? And heterogeneous computing, which is where we're headed, and most of the world is, already on their way. So there are things like ECP, which is coming to an end. That's the DOE's exascale computing project, right? They have a software stack. There's domain-specific languages which people are having success with, and other standards like C++, right? So I think there'll be a mix of how we engage this. The DSLs, I think, look the most promising from my perspective, but I think you guys have a better vantage point than I do. And we need to address multiple processor options, right? So I think HPC systems in the future will not be, a bunch of x86 cores. They won't be a bunch of ARM cores. There's going to be a mix of things. And we're going to have to get ready for that, right? So again, the question came up about, the investments we're making here, and we're doing that through CINA in the HPC program. We're doing that through supplemental funding. But I think, things that we can think about are how do we approach that as an organization, as a program, as a community. How do we start really looking into those multiple processor options, because they do take a lot of thought and investment to get to. And then you have to think about other things. What language do we use? And people always get it's all doom and gloom when you talk about Fortran, but Fortran's never going to go away. They keep saying it's going to go away, but it's good. We're fine, right? And it's gotten a resurgence in the community. There's actually a package manager. That people can use. That's like a lot like Python. So there's a lot of growth in Fortran. So I don't see it too much of an issue with it. Containerization, you guys should be familiar with that. I think it's a key component for moving around and being, that abstraction layer for how we run systems. And it is really an enabler for AI and ML. We can tailor a workload stack. The workloads can work together. And this will evolve, right? One of I think my big concerns, and there's not a really a good answer for it in the market, is HPC schedulers do their job, they do it well. Container orchestrators do their job, they do it well. Those two things don't work well together. They do work together, they don't work well together, right? So Singularity is what we have on the R&D HPC, and that does work pretty well. But I think we're gonna have to evolve that software space too. How do we really integrate containerization into our software stack, and then how do we manage it from a system level so that your workflows can happen, and we're going back, adopting kind of the right software management model for your work. I think this is where, software is where the line's going to blur. I think software is the most important thing we're going to talk about. And I think, between on-prem and the cloud software stacks, those things will bleed together. And in a perfect world, right at the end of the rainbow here for me, is that you don't have to care about if you're going to cloud or on-prem or where your job is running. You just know that the software is going to be there and it's common. So I think a lot of those tools from all of these different places, through containerization, through what we're looking at doing with XSL software stacks and other things, will kind of all blend together so that you can move kind of freely from those platforms. Now, is that going to take a lot of time? Yes. It's going to take a lot of effort. Yes. But I think, investments that the HPC program's made and investments that we're thinking about making, along with the investments that you're all making, I think we can get there in small steps, but that's how progress is made, right? So that's going to be one of the focus areas, I think, from my perspective, is how do we get to that software environment where we can manage it, and it abstracts the world enough that you can make it work and doesn't steal from performance, at least in a way that we can deal with it. So I talked a lot about, just the compute environment, but let's take a look at the cloud market for HPC, right? It continues to grow. It grows in NOAA. It's growing across the world, but it is affected by other than HPC, obviously. But the HPC market it's growing, I guess, within the cloud. So this is also from Hyperion Research. This is not my slide. I got to go to their briefing last week, and I stole their slide. So, and this research doesn't show the LLM stuff. So the LLM market really affects both the HPC market. They're essentially the same as hardware. So the GPU scarcity that we talked about in the last talk, that's mostly driven by the large language model development, right? So training these models takes an enormous amount of hardware, and it really chokes the market out, right? We're seeing now, I think the last number I heard was 12-month wait times for an H100, which is the newest GPU that NVIDIA makes, if you're not already in the funnel or the sales pipeline. So if you're going, if you're a vendor or OEM and going to buy stuff now, it's going to take a year. So this is what's driving all that scarcity. And even on the cloud, when you go through our program or by yourself or however you want to do it, getting to a GPU is hard. You have to wait or reserve it and then wait for that reservation to come. So we've seen that in the program. People are talking about that at the show. So there's been a lot of investment, but there's still there's more demand than investment, which is, I think, a story that we're all familiar with, since that's how we've lived for forever in HPC, right? So, but I think the cloud, provides a lot of upside for HPC, right? So that rapid adoption of technology. How do we get to new architectures and software paradigms and things like that? I think a lot of that can be done through the cloud with a low investment. If we want to try a piece of hardware, you don't have to buy it. You can go try it. But that also includes, that also will need a little bit of software work. So, so AI and LLMs are dominant in the cloud market. There are things that are driving HPC workloads to the market, cost effectiveness, right? That's tuning your job, though. That's a lot. That's some work. A lot of surge workloads. I've seen a lot of centers do that. Resources, if we have to run big jobs, that kind of thing. And then again, that access to new technologies. That's the focus, I think, for me, for cloud. How do we get people to new technology, right? We can use it as what we know, but getting your hands on new technology, this is, I think, the best path that we have for that. Just to give you an idea of what large language models consume, this is just kind of the snapshot. Again, this is from Hyperion. This is not mine. But this reflects, I think I've done a lot of work on the large language, well, a lot of research, not work, on the large language side, in my day-to-day work. And this kind of all lines up with what we're at. So to give you an idea of what an investment looks like for a large language model that you may use at home, I think right now with a multi-billion parameter model, the investment to train is almost $1 billion, right? They expect that by 2020, when they're moving to multimodality, the parameters are going up. They're estimating that, I think it was like 5 or 10 million by 2025, right? So the market is consuming compute at a rate that is kind of alarming, I guess. So they're reaching towards from 2010 to now, they're consuming about 60 zettaflops of compute, and it's growing at a higher rate. So a lot of that scarcity you might see in the cloud market because of this, because this is a big ticket item for folks, and a lot of developments going into it. So it's 11% X growth over HPC, the number one. So the market is growing faster than we can than the market puts HPC systems together. So that's just kind of give you an idea. So what are the emerging trends here? We talked a lot about stuff, but increasing heterogeneity in hardware and software. That adds complexity, but it also is, I think, in my perspective, a benefit, right? We can work to abstract things in hardware and software so that your job gets easier and you have more choices. So that means we have to be a little more flexible. We have to work through integration and make sure that we can get to a place where we can work towards rapid development for emerging and growing workloads, right? So your workloads are becoming more diverse. They're adding AI, they're adding other things. How do we grow to add that flexibility so that you can move there faster? Cloud continues to grow, but it's being consumed in other ways. I think it's a really good tool for development. I think it's a really good tool for testing things at scales that we just can't provide. I think it'll be a growing tool in things like production. But we'll find a balance point, right? And we'll continue to watch that. So I think we'll all grow together, but I think it's going to be an interesting couple of years with the market the way it is. So just, we talked about technology. There are opportunities for training and development, right? We need to provide those. We do through the HPC program with our partners in industry. So there's boot camps, there's hackathons. We want to make sure that we link those things back to existing resources or other resources, right? So what I think we have a boot camp coming up in January. There are hackathons. There's the incubator program, right? So if you have a HPC or technology idea, you can put together a small proposal, make sure that we're getting good ideas into your job streams and really fostering that so that you can get some resources to get that stuff done. So if there are other ways that you want to get training or other places that we need to look at, I'm open to suggestions. We can certainly work together to get there. And I think it's something that we need to talk about, right? We are going to need to develop workforce, okay? So we talked about hardware, we talked about software. Now let's talk about the important part, people. Having a pipeline of technologists, having a pipeline of engineers, having a pipeline of scientists, right? We have to start building that. And we're not at a disadvantage, right? We have a great mission, we have a great organization. Industry is moving rapidly to hire people. They kind of go through these spurts, and they're in one now. We start building that workflow. So we're working on ways to do that. Again, if you have suggestions or ways we can partner, I think we need to do that. We need to do work. We need to build workforce. So good, bad, or indifferent, gave about 5 talks this week at SC. That's way too much. You should not commit yourself to that. I don't know how that happened, but it did. And every time I was on a panel or at a session, someone said the word workforce, right? So we're in a crowd of 12,000 people, 14,000 people, and everyone's still talking about workforce. So this is something that we're talking about in the HPC community, it's in the technology community, in the AI community. I'm sure in yours, it's on the science community. We need to start building and reinforcing workforce. And that means investing in the people that we have. That means investing in new folks that, we can hopefully recruit later. That means outreach to students, building pipelines for students to come into our programs as technologists, as scientists, as engineers. So I'm going to get off my soapbox about training, but that is one of the things that I think, I really want to reinforce. We have to start talking about workforce development. So what do I think about the future of HPC and NOAA? So, obviously we want uniform growth. You guys have a research mission that will transition to operations. We need to make sure that those two resources grow at a uniform rate, right? We don't want too much operations without not enough R&D, and if we have too much R&D, there won't be enough operations to meet the developments that come into it. So how do we find a good place for uniform growth? We need to, like we talked about the whole time, effectively invest and innovate with technology, right? We have to gain capacity with capability, right? We can buy compute, it's not going to get faster. We have to invest in software architectures, whatever, to make capacity become more capability. And we have to build towards what I think is a future state of computing, right? We think of an HPC as a system as a system. I don't think that will be that way in the future, right? With AI and edge and everything else, right? We're going to spread the edges of these systems, and workflows will span across those. And how do we deal with that? So we have to start really building towards that kind of value stream kind of view of the Earth system prediction. So that'll be another thing that we're working on, hopefully with you guys, to kind of work that out for the future. But that is a long-term view, and I think we need to keep going towards that. And modernization that embraces you, right? User input, you guys have to be involved the whole time. We want to make sure that you get the input and are involved in the process throughout. So modernization that focuses on the user, and I think that's my last slide, and I'm happy to take questions. And thanks for letting me do this, and it's good to talk to you guys.
All right, thank you, Frank. We've got about 20 minutes set aside for discussion on this topic. So if you want to hang on the line and address comments, concerns, questions people have, that would be great.
No.
Shujin, grab the mic.
Frank, what is your vision on the RDHPC compared to the operational HPC? So the proportion, because right now you have, I can see your part probably more than 300 million there. So how much you buy for RDHPC and PCS, and how much you want to buy for operation?
So I don't know. That's a good question. I don't know if I have the right answer for it. I think this is one of these things that we need to kind of, it's always been like an ongoing discussion, I'll say. But I think there needs to be more R&D, right? And what I think we need, and I think what's going to happen over time is that the base, we may get to a baseline, say it's, 3 to 1, 5 to 1, whatever that may be. And it's going to be what the budget allows us to do. But I think we have to be flexible and understand that has to change over time, but we may have to, pick a baseline. Maybe it's 3 to 1, right? And I don't know if we'll get there in what we have funding now, because we're funding both sides, and that's a good thing. R&D is growing. So I'm not answering your question, and I'm not meaning to duck your question. I just don't think we have an answer as an organization, and we have to work towards it. Hopefully that's helpful. I'm sorry, I didn't have
there's no right, wrong.
Yeah, no, I know. It's just, I think it's one of those things where we just have to have the discussion, but I agree. I agree with you. Not agree with you, but I think I'm in your line of thinking. We have to kind of come up with, here's how we're going to make investments, right? And that's what I've been driving towards. Like, here's the 10-year outlook and how we're going to grow, kind of thing.
Frank, I had a conversation with Bill Ramstrom from AOML and CMIS yesterday, where we were kind of talking about what you were touching on about the edges of the systems and the workflow being a little more agnostic than they are. And I'm not well versed in this stuff, but I was wondering, is that approaching something like distributed computing, where we would put DA on one system, so that it can get restricted data access, and then other parts of the workflow and other systems where it doesn't have to have that restricted access?
So, I mean, it could. I think of it I think of it a little differently, right? So I think there's. All right. So let me, before I answer what I think the question is, I'm going to answer, what you're asking about, where people have different access needs, right? So I think we have to get better at that, and it's not I mean, the industry, right? The way we do it is the way we've always done it, because that's the way the system let us do that. I think we have options to make that better, right? So I think there are technical things that we need to start looking at to make that process of who can see what and where and how better. And I think we're getting there, especially in places like cloud. Now, when I talk about how we're going to stretch the workflow out and that kind of thing, I think of it more as, well, in a perfect world, and we're not there, you would start processing of things like DA is a good example, right? Or maybe I'm thinking the wrong part of right. So if I use the wrong acronym, I realize that I'm not a scientist, and I apologize. But if we can start processing of inputs faster and put them in the right place at the right time, and then get all the data later, but we got the part that we needed, right? And that's not really the right way to say it, but how do you make that whole chain speed up, right? So you're going to stretch the processing out across a bunch of different assets, right? Maybe two, maybe a bunch, right? Or if you're taking sensor data in and you start processing in the field rather than processing when you get the data back. Does that make sense?
To me, I think so, but I'm kind of in the same boat you are. I may have a science background, but it's not to do with HPC and so forth. But Bill's got the mic, so I'm going to defer to him.
Yeah, this is Bill Ramstrom. So my thought was more actually for our sort of canned cases. So it's not really, the latency isn't really critical on them, but it was more a matter of, we have these restrictions of where the observations can be put onto different systems. So, if we ran the DA and digested it into a relatively compact package of data that, was no longer considered restricted, then we could, throw that to, maybe a less secure cloud server or something where, it's just a, an analysis of the current conditions. Because what I think of is when we run like a 3-year retrospective of cases to test out as we're approaching operations, the cloud seems ideal for that, of this really peak amount of compute that we need for, once a year perhaps. That, but I think right now the restricted data, makes that challenging.
Okay. So I think that's it's a problem, right? And we've had to work through it in R&D a couple times with partners, and it's not an easy thing. And I think that's one of the biggest things that we should, those discussions should start soon, right? Like, how do we make data available in ways that we haven't before, right? So there's the market's evolving, right? Everything's software, and we talked about that for a little bit, but how do we find solutions to make things available to the right people at the right time? And usually we've done that the way we've always done it, where get an interconnection agreement and we do the security stuff, and we're still gonna have to do that stuff. But how do we make it so that you don't have to understand the plumbing, right? So if we have a system that covers NOAA, right, we can build access into that, where I think right now it's a point-to-point thing, right? So I don't think the market's there. We're working towards it. That's not really a good answer, but I realize that it's one of the challenges that we all have to work through, and I'm focused on it.
I think Gopal's turning on a mic now, possibly. Did you have something to ask Frank, or no? Okay, you're just playing with the technological toys. All right. Are there any other questions or comments in the room? Not to put anyone on the spot, but I was kind of looking towards the EMC folks to see if they have any thoughts on this. All right. Thank you, Alpha. Oh, he's got a choice of 3 microphones.
Yeah, so not on this topic per se, but a couple of things. One is a comment, other is a request. So I was pleased to hear from Radhika's presentation that there is an attempt to unify system configurations across.
Mhm.
And that, I think, will go a long way in helping all our community developers to port code and exercise the code with uniformity of utilities and libraries which we need.
Mhm.
So that's a very healthy development, and however much we can unify and synchronize across, the better off we'll be. Ideally, all of this should not be too different from WCOS2, but I understand there are other considerations which force things to be different on WCOS2. So that was my comment, and I appreciate that attempt from OCIO's office. A request is in context of access to our HPSS archives.
Mhm.
So from some systems, example, HERA, it is relatively straightforward. We have access to everything which is made available on HPSS. And this really helps, if you can think about it in context of conducting real-time experiments, where we want to run everything off production results from GFS.
Mhm.
And so having direct access to that data quickly, don't have to spend and worry about multi-step data transfers.
Mhm.
But unfortunately, this is not the case for some of our MSU assets like Orion and Hercules. Those are very useful machines, and as time goes on, actually, our performance and our use for those machines is becoming more than what, say, we've been using, how we've been using HERA. So that's again very healthy.
Mhm.
But access to HPSS remains an issue,
Yeah.
especially for real time. So I know there's no quick solution, Frank.
Yeah.
Radhika. I know you guys have looked at this. We've been complaining for a while.
I know.
But as we go forward, something to keep in mind if this can be somehow mitigated.
Yeah, and I know it's it's an issue, and the unfortunate case is that you make things more open on one side, and that causes issues on the other, right? So, but I think and you guys have heard this before, but software, there are ways we can think about solving this through software. There are ways we can think about solving this through things like caching, but I think there's more technology out there that we can now look at that would maybe help these things. Like, I think this is it's almost like the last question, right? Where we have all this data, it's in different places. We want to make it available as much as possible. What's that framework look like? Right? Where, I mean, there's stuff out there now that makes allows you to treat your data like Python modules. Like, how would that look, right? And how do we make those things usable? So yeah, I don't have a good answer for you, but I think we're trying to look at it from multiple perspectives so that we make it easier for you.
Thank you, Frank. Are there any other questions online or in the room? If not, I think Shujin has one more. Oh, Zach, it looks like you're getting tapped to talk. Uh-oh.
No one? Then I ask another question. So in your slide, you put LLM. So probably most of people here don't know what an LLM.
Oh, sorry. Yes,
That's a good
that's
question.
good question. Okay, so thank you. I am sorry I didn't have that context for you. So an LLM is a large language model. So I'm sure everyone's talking about them, but things like ChatGPT, that's an LLM. Bard from Google's an LLM. And just to, give you more context, right? This is a policy issue within NOAA and one that we're working through. So the DOC issued a policy on this in July, and now I think it's out into NOAA. So we are working towards pilot programs for large language models. I think there's been a lot of really good developments in the space to make them more accessible for us. So companies like Google and Amazon and Microsoft all have ways that you can get to those models without exposing your data or exposing, other things into training of these big models, right? I think that's the biggest concern on the security side. Maybe you've seen stuff in the news where I think an employee from an electronics company put in a spec to get a summary written for him or them, and they released basically the whole product line spec into the public, right? So those concerns are out there, but I think right now we're working towards a world where they're not going to be that concern for too much longer. Now I think one of the big public models like ChatGPT or Bard, those are still going to be, not something we may engage with work, but there are versions of them that we will. So hopefully that's enough background, but I'm happy to answer a question about the policy too.
Yeah, no, this is like a lot, enough educate us to get the knowledge. And my point, I asked that's not real point. So I ask you the background. The real thing is that it's basically is the generative AI. So
Yep.
So that is I just learned that. Okay, so yesterday Dave Nioki gave a talk. So his basic information is from generative AI. So yes, no, I have certain policy not use that or use that, but this application just start booming from academia. So what I want to make the point is we need this kind of expose and education. So that's my real point, is that the training is really important for us, and I will continue to voice that. When you do the big purchase, don't forget there's a small portion, leave it to training to scientists and engineer adapt this kind of transition, because it's used natural language. How many people know natural language here? So it's a totally different domain knowledge, and I would say average scientist knowledge, 20 years can last 20 years, but the computer domain probably 6 years or less than 6 years. Need to update whole knowledge.
No, I agree, and I think with the training is not just on the technology, right? The training is going to be throughout the process. So, and this is different from maybe other agencies or other missions where there are legal concerns, but even in our realm of the world here, every data set that we have that we use probably has a bias in it, right? And we work through that, and we do that, I think, normally. But I think we're going to start having to have more discussions about, before we put data into these models and train with it, like, are these biases that we can deal with? What are the ethical implications of this data being used, or what's missing, and what are the ethical implications of that? So I think it opens up, to your point, I mean, just not from the technical side, but from a holistic approach, like training and education in this area or around this technology, I think it has to be central. It goes back to my workforce thing, right? This is part of that. Like, we need to prepare for it, and it can't be just, here's a tool. Because I don't think, you might get what you want, but you're going to miss the kind of, I think you're going to miss the big picture stuff. Not miss the big picture stuff, but miss the larger ways you can implement it to help you out, right? So I think it's really important, and I'll support